Let's now represent a diesel cycle in an indicated diagram. A diesel cycle is once again the name of a theoretical cycle that is used in order to describe what's taking place only in compression ignition four-stroke engines that are usually called diesel engines. But be careful, it's called diesel cycle, but it's still theoretical, so it's not describing what is exactly taking place in a diesel engine, but it's the most basic assumptions or most basic cycle in order to describe it from a thermodynamic point of view. So, as for the Otto cycle, we don't have the admission and expansion, so we start at the end of admission. So admission or atmospheric pressure and bottom dead center, so maximal volume in a point that we will call 1. As for the Otto cycle, the compression is considered as adiabatic and reversible. So we have phi times v at the power gamma is equal to a constant, and then the shape is hyperbolic at 2.2 there for the compression. So it's very similar. The only difference with the Otto cycle is that here V0 will be lower compared to Vmax because we have a higher volumetric compression ratio for the compression ignition engines. Then, second step is the combustion. One of the specificity for the compression ignition engines is that the combustion is slower, because we need the time to inject the fuel in droplets, we need the time for the droplets to evaporate, and then for the fuel vapors to mix with the combustive vapors in order to have the ignition. So this combustion process is much slower than for the spark ignition engine. The combustion is an input of heat that tends to increase pressure and temperature, and the expansion that is taking place at the same time tends to decrease the pressure and temperature. For the diesel cycle, we do one big approximation. We consider that from the pressure point of view, both processes are equilibrating. That means that we consider that it's an isobaric transformation. The pressure remains constant during all the combustion. So here we have a horizontal transformation from 2 to 3 that corresponds to combustion, but also to the first stage of expansion, because expansion is taking place at the same time. Then third transformation is the rest of the expansion, and now that the combustion is over, we have again we consider again that we have an adiabatic reversible expansion with the same shape that what we have for the compression at 2.4. So that will be the second phase of expansion. And the last transformation is exactly the same than for the Otto cycle. We have an isobaric cooling. So isobaric cooling, allowing to bring back the fluid in the same state that we had initially, and this transformation is replacing exhaust cooling of the smoke and admission. So that's for the diesel cycle. which is the most basic theoretical cycle for the compression ignition engine.